Hello everyone. Bismillahirrahmanirrahim. Uh, Welcome to Math School. Today I am going to give you a lecture on metrics. Actually, I have planned to give you lecture in two different parts. So today I'm just giving you lecture as part one on metrics. Okay. So I'm going to share my slides here. Uh, so let's start here with the slides. And all right, so metrics, basically this is a singular word. In plural we call matrices. Now question is, what is a matrix? A matrix is a system that encloses some elements in a systematic manner by parentheses. Uh, that is, the elements are arranged in rows and columns under some properties, of course. So that means matrix is basically, it encloses some elements and we use a parenthesis, especially first bracket. Yeah, sometimes square bracket is also used. And elements are arranged in rows and columns, and there is some properties. There are some properties, and matrix always follows those properties. Without those properties, matrix cannot work. Let us have an example here. Matrix A, the elements are, you see, 3 and 6 and 4 and -3, in which we see the four elements here, 3, 6, 4, -3. These are all placed in two rows and two columns. Here, 3 to 3 and 6, this is in one row, 4 and -3, this is in second row. Actually, horizontally, we call these array as rows, and vertically these are called columns. Say 3 and 4 in first column, 6 and -3 is in second column. So vertically we call column and horizontally we call rows. Okay, now we have to know one more thing, very important thing, that is uh, order. So order of a matrix. Okay, what is order of a matrix? We should know. Um, Basically, order of a matrix is number of rows versus number of columns. So we write it like this: order of matrix equals to number of rows. Here is a cross sign. We read it as actually by. So number of rows by number of columns. So if number of rows is m and number of columns is n, then order is equal to m by n. So which is read as m by n, you see here. So m into n, don't say like this, or m times n, you should not say like that. You should say m by n. Okay. So here our matrix A, we see the elements here 1, 7, -3, 2, 4, 8. Its order is actually, you see there are two rows and three columns. So its order is 2 by 3. Similarly, matrix B, there are actually three rows and two columns. Okay. So its order is 3 by 2. And matrix C, its order is here, you see, um, uh, just one row and two columns. 2 and 7 is in one row, 2 is in one column, 7 is in another column. So its order is 1 by 2. So now uh, calculation of matrices. If you want to calculate the matrix, then you need to know, basically we do subtraction and we do, addition and subtraction. So when you are going to do addition and subtraction, just you have to see something, that is the order. If the order of the matrices that you want to add up or you want to subtract, then their order has to be same. So if the order of the both matrices are same, then only you can add them or you can subtract. So here we see some examples. Here matrix A, you see matrix A is 3, 4, 2, 0, 6, -2. B, and the elements are 8, 4, 9, 0, -3, 1. C is 4, 2, 3, 9. And now if you want to add matrix A and B, you see their order is same. The order of matrix A is here 3 by 2. Order of matrix B is also 3 by 2. So if you want to add them, you can do it. And remember, when you are adding them up, always you have to add the respective elements, the corresponding elements. Say 3 would be added to 8. 4 would be added to 4. 2 would be added to 9. 0 would be added to 0. 6 would be added to -3. And -2 would be added to 1. Why? Because they have same place, position value. For example, the 3 here, the position is row 1, column 1. Here 8 is also row 1 and column 1 of the matrix B. So their position is same, they are corresponding elements, so we are going to add them up. So similarly, if I think about other elements, say here, for example, say 0, its position is what? Row 2, column 2. Here, the 0 is here also, in other matrix, in same position, row 2, column 2. So we can add 0 and 0. Similarly, if you want to add 6, 6 position is row 3, column 1. And here, -3 in the other matrix, you will see that this -3 is in row 3 and column 1, same position. So that's why we are going to add. That means when you are adding two matrices, always you have to remember that you are going to add the elements of the corresponding elements. That means elements of the elements having same position value. Okay. Similarly, when you are going to subtract, always you have to do addition and subtraction in same way. But for addition, you have to add. For subtraction, you have to subtract. So everything is same, and their order has to be same. So here A and B have same order, as you know. So we can subtract them. So 3 minus 8. Here 3 minus 8. 3 and 8 is of same position. 4 and 4, they have same position value. That's why 4 minus 4. Similarly, 2 minus 9 here. 2 and 9 has same position value, and so on. So subtraction is also just like addition. Everything is same, but addition is to be added and subtraction is to be subtracted from one or one from other. Okay, so now let's see if we want to add matrix A and C, what happens? Actually, matrix A and C, they are not of same order. So you cannot actually add them or you can subtract them. If you do, what happens actually? 3 and 4, if you add, fine. 4 and 2, if you add, fine. 2 and 3, if you add, fine. 0 and 9, if you add, fine. But if you want to add 6 of matrix A, then you can't find anything in matrix C. So there is nothing here. And -2, you cannot add anything with of any element of C. So that means it's not possible. So that means when you are not having matrices of same order, you cannot add them or you cannot subtract them. Now multiplication by a number. If you want to multiply a matrix by a certain number, what can we do? Actually, this is very simple. This is called a scalar. A scalar can be multiplied with a matrix just if you multiply the matrices, elements of every element of the matrix just by the number. That means 3 is multiplied with 2, multiplied with -1, multiplied with 1, multiplied with 4, and you get the values are all multiplied by 3. Entire values of the element matrix is multiplied by 3. And thus you can multiply a matrix by a certain number or a scalar. Okay, that's it. And now if you want to just do calculation, just A and B, then A is multiplied with 2 and 3B is multiplied with 3, and you want to add them. So simple way, first you have to multiply the number in the matrix here, and 3 is also to be multiplied with matrix B. So as a result, we see the change here. After multiplication of 2 with A and multiplication of 3 with B, you see the values are changed. Now you have to add them accordingly. So 6 would be multiplied with 24, 8 would be multiplied with 12, would be multiplied with 27, and so on. Because of the corresponding position rule, you have to just select the elements to be added. So first, what you have to do, you have to multiply the numbers first, okay? Then you can add them or you can subtract them. I think you understand, okay? So simple thing. So multiply the number first with every element. So 2 times 3 is 6, 2 times 4 is 8, and so on. These are all changed. You see, multiplied by 2. And this is multiplied by 3. And then you add simply. Okay. Similarly, if you want to subtract, if there is a subtraction sign here, we'll just subtract. After multiplication, you will subtract. And finally, you get this result. So this is the, after the result, we get one matrix. The addition is a matrix here. Multiplication between the matrices. Okay, this is very important and they're very simple though, but sometimes students get very confused. They mixed, they are sometimes messed up. Actually, we can do it if we just follow some rules, then it's very simple. Okay, before multiplication, first we need to check the compatibility of two matrices. If you see, if you want to multiply two matrices, first we have to check their compatibility. If they are not compatible, we cannot multiply. So what is the compatibility here? That means here, if you see in matrix A, the order I have written L by M, and the matrix B, its order is M by N. If you notice, I have marked by red color here, M. That is a column of the first matrix, in matrix A, and row of second matrix, that is matrix B, they are same. That is the rule. If you want to multiply two matrices, always you have to remember that is the first matrix column number should be equal to the second matrix row number. So that means if the column number of first matrix is equal to row number of the second matrix, only then the matrices are compatible. That means you can multiply. So matrices are eligible for multiplication if number of columns of left-hand side matrix is equal to number of rows of right-hand side matrix. That is the rule that you can check the compatibility of two matrices. I think you understand. And let's see here the matrix A that we used for addition and subtraction there. These two matrices, if you remember, A and B. Okay. No, sorry, I'm using another different example here. Okay, say A is a matrix of order 2 by 3 and B is a matrix of order 3 by 2. Okay, if we want to multiply A and B, what will happen? So column number of first matrix is 3 here and row number of second matrix B is 3 here also. So they are to be cancelled out. And what will remain? These two and these two. That is the dimension order of the product matrix would be 2 by 2. So that means we will cancel out the column number of first matrix and row number of second matrix. When they are equal, they will be cancelled out. And the remaining dimension, that is 2 here, row number of first matrix, and these 2 here, we see column number of second matrix, that would actually will give us the order of the product matrix. So here this is the example. So A is matrix with elements 3, 0, 2, 4, 1, 0, 2 by 3. B is the elements 2, 4, 3, 1, 0, negative 2. The order is 3 by 2. So that it will happen if you multiply A and B. That would be giving us a 2 by 2 order matrix. And if we multiply here, you see here I'm going to multiply A and B here. Just see. A, as you know, A would be a 2 by 2 order matrix. So its position would be every element would be first element would be row 1, column 1, second matrix row 1, column 2. Second element. Here the other element is row 2, column 1, and then fourth element is row 2, column 2. So now why I have written this, because when you are going to multiply, you have to select according to the position of the element. The rows and column. That that first matrix. From first matrix, we will use rows only, and second matrix, we will use column only. So the first element, as you know, row 1, column 1, I am going to use this row 1 and this column 1 to make this element row 1, column 1. So this is the way. And always remember the corresponding element here in a different way. That is the first element here, 3 in matrix A, and second element, and in matrix B, the first element in column is 2. So 3 and 2 would be multiplied. Then second element of row 1 is 0 and second element of column 1 is 3. They would be multiplied. Here third element and row 1 is 2 and third element of column 1 is 0. So they would be multiplied. That means first element of row would be multiplied with first element of column. Second element of the row would be multiplied with the second element of the column. Third element of the row would be multiplied with the third element of the column. And this is when you are choosing the appropriate row and column. This has to be happened for a particular row and column. Similarly, say I want to select, I want to discuss about other elements, say row 1, column 2 here, you see. Row 1, column 2, this is one element. So how to get this element? That means you have to use row 1 from matrix A and column 2 from matrix B. So, and if you multiply the first element of row 1, that is 3, and say first element of column 2, that is 4, you have to multiply, then add 0 and 1, then add 2 and -2, multiplication of -2, 2 and -2. That means you have to multiply the first element and first element, then add, then second element multiply, then add, then third element and third element of the row and column. So this is the way. That means this is the only thing that you should remember. For example, this element row 2 column 1, what to do? Row 2 here and this column 1 I'm going to use, and this would be the element. And first element of row 2 is multiplied with first element of column 1. Then addition sign would be there. Then second element would be multiplied with the second element of that column. Then you have to add the third element, product of third element and third element of the row 1, row 2 and column 1. So this is always you have to remember. So remember, first you have to think which element you are going to find out. Know the position of that element, and accordingly you have to select the row and column from the first element row, from the first matrix row, and from the second matrix you have to select the column. Then multiply the element that I said. First element of row will be multiplied with the first element of column. Second element of the row would be multiplied with the second element of the column, and third element of the row would be multiplied with the third element of the column. And in between of every multiplication result, you have to put addition sign. So ultimately it would be the addition of the products of elements. So this is how you can get the calculation of the product of two matrices. That means first you have to check the compatibility. If that is the row number, column number of first matrix has to be equal to the row number of the second matrix, and if they are equal, then this two dimension will be cancelled out. Then remaining dimension will give you the order. Say here we used example here, okay, 2 and 3 and 3 is gone, they are same, and 2 by 2 is the matrix order of the matrix. Okay, now if we change the order, say B, I am writing matrix B first, then matrix B second, and then what would be the order here? Are they compatible for multiplication? Can we do the product of BA? Let's see the compatibility. Yes, B's order is 3 by 2 as you know, and A's order is 2 by 3. And here row and row is equal, column of B is equal to row of A. So they are same, so you can cancel them out. Then so remaining element, dimension is 3 by 3. So the product of AB will have, BA. There should be a correction here. Not AB, this should be BA. Okay, this should be BA. There should be a change here. Okay, so if we go for this should be a change here. Let me make the correction right now. I'm going to do it. Yes, there is the correction here. Fine. Now we can start. Now we can start the slides again. Okay, so Here we made the correction. So it is BA. So the order of BA is 3 by 3. All right. So now if you multiply B and A, so since there are it's a 3 by 3 order matrix, there are 9 elements. You see row 1, column 1, row 1, column 2, row 1, column 3. Then second row elements are row 2, column 1, row 2, column 2, row 2, column 3. The position of every element that I am seeing. Row 3, column 1, this element's position is row 3, column 2. This element's position is row 3, column 2. So when I'm going to find these elements, accordingly, I will select the row and column. That is, row would be selected from first matrix, that is from matrix B here, and column would be from matrix, second matrix, that is matrix A here, okay? So now when you are going to multiply them, okay, so accordingly is the first element and first element here, then second element and second element would be multiplied, and in between there would be addition sign. That is 2 times 3 plus 4 times 4. Then this element is what? Row 1, column 2. Row 1 and column 2. So 2 times 0 plus 4 times 1. And so on. So thus you can find every element of this product, and thus you will get, ultimately you will get this matrix, which is a 3 by 3 order matrix, that is BA. Now one interesting thing, that with the same matrix A and B, when we multiplied A and B, we found a 2 by 2 order matrix, and when we found we multiplied B and A, we found a 3 by 3 order matrix. That means it's interesting thing, when we multiplied A and B, it was just 2 by 2 order matrix, and when we multiplied B and A, we found 3 by 3 order matrix. As you know, that in case of multiplication of two numbers, say 5 times 7, here you see, and 7 times 5, they are same. 5 times 7 is 35, 7 times 5 is 35. So they are commutative. That means normal numbers, when they are multiplied, they follow commutative law. But when we are multiplying matrices, A and B and A, we see they are different, so they are not same. So that means matrix does not follow the commutative law. That means you cannot say that, not necessarily that AB would be equals to BA. Matrix A times B would be equals to matrix B times A. You cannot say that. Not necessarily it would be like that. Okay, usually they won't be equal. So A times B is not equals to B times A. So that means matrix does not follow the commutative law as normal numbers follow. Okay, so that's all for, lecture 1. Then I will discuss the rest of the thing in lecture 2. Okay, so I think you have understood. Okay.